Okay, so when you're having numbers like this, all defined as integers, you always get integer return. Okay, uh, what is the good part in this, and what is the bad part in this? Can you tell me a good part? If I have a number, all integers, and I have a division to process like this, what do you think the good part in this? Any idea? Anyone have a guess at least?
You always get a rounded number.
You get always a rounded number, that's right. Yeah, there's a good part on that as well. If you really want to divide some, distribute some food or something, if you want to count like number of people, right? Number of people is never going to be a half, right? In that case, rounded number is always good. Yeah, so what are the other benefits? So it's depending on the application in that case, yes. But in performance wise, what is the good part?
There's
It
less
looks a little
episodic.
nicer.
Say it again. I did not hear you right.
I said there's less like to store in the memory.
Yeah, so it is actually when we were talking about earlier how these things are stored in the memory, right? Floating point numbers has three pieces. One is the sign, one is the exponent, and the mantissa, right? So exponent is like if I have 25.77, I can write this with dot here and 577 multiplied by 10 to the power 2, right? So this is a form of writing this one in a different way. So in that case, I can store 2 here and store this number right here, right? So this is how you actually store this number. In that case, you will have 2 of them, different numbers, and then when you divide it, you will have another piece of the same kind. So if this is the case, if I have to do this, the problem in this case is, yeah, I have to store it in this kind of format. But in the integers, you don't have to worry about that. So the integers is just a number. I can use this a plus or minus here, and then I can put the number, right? And this is the other structure of integers, right? Plus or minus, and then the number. So the answer, whatever I get, will be the same, right? So there's no conversion, there's no preparation like a floating point number here. So it is a lightweight operation for the computer as well, okay? So even you don't think about this far when it comes to the division is a heavyweight program process in order to calculate, especially in the floating points, okay? Handling floating points is the hardest thing to do in the CPU. So as I said before, that is why the flops came up. Flops is a floating point operation per second, uh, floating point operations per second. So this will measure how fast your CPU is and how much it can do within a second. So this is what this means. So if you have ever seen a hardware specifications of a CPU, or if you are measuring performance of your computer, uh, one of the most important part is see how many calculations it can do per second, right? Uh, so why flops? Because it's expensive operation, right? You can do double the work if you're using only integers. That is a good part. But what is the bad part? So can anybody tell me what is the bad part of using integers?
It could be less accurate, maybe.
Yes, exactly. So it is not accurate, right? So if I use float, right? If I use float, yeah, of course, if I divide 10 by 4, it should give me 0.5. So there's accuracy of this. If you only get the answer as 2, there's an error margin of plus or minus 0.5, right? Okay, so like that. So if you want to get precise values, the float is good to go. So what's the difference between float and double in that case? So what is the advantage of using double instead of float?
Double can store larger numbers than the float.
Yeah, I mean this larger decimal numbers, like for example, more decimal numbers can handle by this, right? And float usually for the currency, the float is good because it can have only 2 point numbers like that, very small numbers. If you want to have only 2 digits, this is good for float. But if you really want to take care of larger decimal numbers, you go with the double. Okay, so that is the difference between float and double, and the advantage of using integers and disadvantage of using integers. Okay, so if you know all that, this is what they're discussing here, the reasoning and why is it important. So go through this. So spend a little time, go over this, and then try to understand what it says. I don't wait until the exam to go over this. This is so much, so much stuff that you have to read and understand. It is time consuming. So in that case, if you love yourself, just study this by yourself. I mean, go through these exercises by yourself. If I start going through these exercises, I won't cover the whole thing about C, C++ in this semester because it's longer than the semester if I had to go that. So that's why I'm just skimming through on all the exercises here and make you have it when you're studying, okay? All right. Yeah, so when you divide 13 by 3, actually you get 4 as the answer, right? Yeah. So why those are integer divisions, right? What about this? 4 divided by 9, what do you think you get? Those are integer divisions. What do you get? Usually what you should get. You get something point, right? So, but it is an integer division. So you get 0, right? Yeah, yeah. So you get 0. Why? The number in the top is smaller than the number in the bottom. So you have to get point value, but this is an integer division. In that case, you get 0, right? So things like that, be aware. These are some exercises just to point out. But if you have something like this, if the one value of it is a float and the other is an integer, is always the system will put these in the floating point registers or the floating point, the version of it. So in that case, if you divide integer 10 by 4.0, this operation, even whatever the output, regardless of an integer answer or the floating answer, but the operation will done inside the computer using the floating point register or the method they use for calculating floating points. So that is one thing that you have to be aware. Again, repeating what I said is, if you have integer values to divide like this and get the answer as an integer. So this is int, and this is int. In that case, they will use the lightweight operation on the structure like this, right? And then the answer. But if you're using something like int value for 4, and then if you have something here 2.0, which is a float or a double, right? And this answer, even the answer is an integer that you need. In this case, they will use floating point operations. In this case, you will have 3 sections in your register, and the answer will be 3 as well. Okay, so that is something which is compiler does. If you're using only integers, they will use this structure. If you ever have anything like this inside your program, then they will use this. Okay, so that is something that you have to keep in mind. That's something that pointing out here. So it is 2.5, of course, the answer. If you're requesting only answer as an integer, then it will give you 2. Right. So that is something that system will do. All right. So division by 0. Obviously, I've talked about this before. Why is it matters? You can define variables. Like for example, this is a salary example. So let's say you have integer a num, and then you have even as a float, doesn't matter, b num, right? So, and the answer is equal to a num divided by b num, right? So if you don't check what is b num is, this answer sometimes will give you different numbers. Like for example, if this is 0, right? In that case, it is an infinity. It's not a valid value. So infinity either is defined by this or it will go undefined, right? There are so many ways they come up with this value, right? So it's better you check this. How do you check this? You will learn if else next chapter. You say if b number is not equal 0, right? Then you do this. I have seen some people do here, instead of this, they say if b num is greater than 0. What happens if I have only this? What is the error here? Anyone?
Enum isn't initialized.
Oh, well, you can initialize this to something, of course. I mean, you can say C in, let's put that, C in B num. Right. What I'm asking is, B num is an integer or a float, whatever. And then you have to check before you do the division, is it 0 or not? Because if the number is divided by 0, you get undefined or the infinity, whatever, right? So it is, the answer is not right in that case, because you cannot divide, you should not divide anything by 0, because the computer don't have an answer for that. So to check whether is it 0 or not, you can do if the b num is not equal 0. That's a good one. But I have seen some people doing if b num is greater than 0. So what I'm asking is, if I'm using a greater than 0, what is the problem here? Why is it a not good way of checking whether it's a 0 or not? This is logical thinking. Why is it not good?
Because then you wouldn't be able to get when b num is less than 0.
Exactly. So if I have if I want to divide something by -5, for example, right? If this is the b num, if somebody enter -5 as your b num, right? Like in this statement, somebody entered -5. So in that case, your answer won't be exist if you do this statement, right? So because b num has to be positive value in that case to do that. So it's not covering the negative value. So that is the way of thinking. When you writing programs, you should be aware of things that is all the possibilities you have to think of, right? So one thing is that means you should think of all the possibilities can happen. Sometimes a b num can be a negative number. In that case, if I put this if statement, the program won't work. So you may have to think of that things as well. So yeah, that is the critical thinking. Especially you have to see the requirement of the user for the program that you're writing. And then also you have to think of all the possibilities can happen, right? So this is a good example of that. This is a very simple concept I just point out here, but this has a very big meaning. How and what kind of instructions you should use, or what kind of logic you should apply for your program. Okay, so keep that in mind when you're writing programs. This is also very important, right? Okay. So the division of 0 is a very common mistake with most of the people does. They are not aware that this value, whatever you're dividing is, can be 0 or not. Keep in mind, if your monkey mind running around, bring it back for a moment, which is addressing this point about the division of numbers. Make sure your dividend is never be a 0, okay? Okay. Right, so the modulus or the modulo, what is this? What is modulo? Do you know? Anyone? Math people? What is this used for?
Reminder.
Remainder, right? So it's a remainder actually. So if I divide something by something, right? You can get the whole value of this is 2 and the remainder is 1, right? So this is what actually the whole story behind this, right? So this means 2 multiplied by whatever the value here, right? 2 in this case will give you 4, and then the remainder you add to that will give you 5. So this is what it means, right? So if I want to extract only the remainder part, then I'm using this symbol, which is called modulus, okay? This is works only for the integers. So that is another one you have to keep in mind. If you're using an int a, and if you're using int whatever b or something, and a is 5, b is 3, let's say. So this is the only way that only time that you can use modulus. So the answer I can have also integer value, right? So these are only for integers, okay? Keep in mind. So a modulus b. This will give you what? What is the value it give you? A modulus b, e modulus b. What do you get? If
2.
Yeah. So if this is a program, give it 2 as the answer. Okay. So this is very important. Okay. So let me give you a good example of this. I think I went through this. If it is not, let's say I have a number 5734, and this is a number, and I want to find if there is number 3 in here. Right, so let me ask, how do you do this? How can I find number 3 is in there? Can anybody think? I'll give you 2 minutes. I don't want to spend a lot of time on this. How do I really going to find number 3 is in that series of letters? I mean numbers. What can you do?
Divide by 3.
Divide by 3 won't help you, right? Does it? So for example, if I have let's say number 27. So if you divide by 3, you get 9. Does that mean I have a 3 in here? No, right? Right? So that won't help.
You could
I'm
use
asking is there an existing number digit 3 in here? That's what I want to find. Okay, somebody said something.
if you use modulo, you can get the last digit, and then if it's not that first digit, then divide by 10 and do it again.
Exactly, yes. Very good. Awesome. Right. So what you do is you get modulus first and modulo 10, right? So I'm sorry, modulo modulo 10, right? So I get modulo 10. So in that case, what happens? When I divide this by 10 means I get 5, 3, and the remainder is what? 4, right? Okay. So what does this mean? Well, that means the 4 is the one which is at this digit right here. So then I can compare 4 is 4 equals to let's say this is number 3. So I have something called num, which is equal to 3 is equal to num. That's the question I'm asking. If it is no, then what I do is my number. So let's say this one is A, for example. My number A is equal to, now I'm going to set this up divided by 10. So if I divide it by 10, I get this because I'm dealing with integers here, right? So that's why you have to deal with integers in this case. So this is the answer now. So this my A now is equal to 5, 3. Then I do the same thing again. So again, I can do the 5, 3 modulus 10. What is the remainder here? What is the remainder? Anyone? 5, 5, 3, 5, 7, 3 modulus 10. What is the remainder?
3.
3, yes. And this is, the answer is 57, and the remainder is 3, right? How do I know? Well, how do I know this is 4? Well, you can convert this back. This means 10 times 573, and this will give you 5,730, and the remainder is, I said 4, so that means 4. If you add these two together, you get the original number, right? In this case as well, if this is the original number, and 10 times 57 is 570, and then the remainder is 3. If you add all together, you get 573. So that's how you put it back together and see whether you get it. Okay, now the number remainder is 3. This is the answer I get from here. So 3 equals number is, so it is yes. In that case, you can stop the program and say, yes, it is exists in your system, right? So you can do that. So that's how you calculate this and figure out whether there's a number digit inside here. So that is a good example of how to use the modular and why you should use it. And there's so many other things that you can use with it, right? So keep in mind that is important. Well, about the parentheses, I already talked about it. Whatever you have inside the parentheses, you operate first. So it is very important that you're using a parenthesis, okay? Right, so rand numbers, we'll talk about the rand later. I don't want to spend a lot of time on it. So let's move on. I think this is all in this chapter. And the type conversion. So I talk about integers, I talk about floats, and then I said, if you're using a division using only integers, you get the answer as integers. And I said also one more thing here, which is if I have one of the variables, like for example, int A, int B. Keep in mind, for the examples, I always use A and B does not have any meaning for the variable. Only reason I'm using a meaningless variables here, just because it's make me write fast, okay? Don't use the same concept when you're coding. Don't write int A and B. have a meaningful variable name, okay? Especially in coding, because coding is, your code is somebody else come and look later on and then edit on it and then move on to a bigger project, convert it to a bigger project. In that case, it's better that you have a meaningful variable name, right? In here, I'm just writing AB because I'm writing by hand, okay? So keep in mind, this is not a good practice, right? But anyway, if I have answer, answer as a float, right? One thing here, even you're doing a floating point operations for this case, right? In the system, if you see any float as this float C, right? Answer is a float. Let's say answer is a float. So I want to point out here, not like this. So, or this is one way. It's one example. Or you can say my integer int a, and so this is answer. Answer equals a or b situation. Or I have a float here. Right. This is a float, and then answer is also float. Right. In these situations, when you're having a over b as your answer, as I said, the system will pick these and treat them as a floating point numbers, right? So especially in this case as well, if I have this one as a 4, this one as 2, and whatever the answer you get, it's actually 2. So it will treat as a floating point number and it will return this as your answer. Okay. So in order to do this, this a, which is number integer value, has to be converted to the float format, right? So this is a float format, right? You have number here at the front and then 2 pieces because you have a dot, right? So this conversion will doing by the system. Integer value will convert it to a float. It's doing by the system. If something happening in the system, this kind of conversions, we call it implicit conversion. So the implicit conversion is something handled by the compiler. Keep those in mind. I would test you those things in your exams as well. What is implicit conversion? So pay attention to all the black bold things on your notes, okay? And notes means when you go through these things, make sure you understand all the black bold terms, okay? Right, these kind of things. So those are things I would ask you in the exam. Obviously your exam is open book, but there are too many of these. So it's better that you have a little idea on it, okay? So I will test your logic more than just the memorizing things because it's open book exam, okay? Right, so anyway, there are so many things that I can ask on this subject. All right, so pay attention, okay? So in this case, it will be doing by the compiler. So there's no worries, yeah, I can use that and then it will do it for you by the system. So that's what we call implicit, okay? And the other type is, so this is the example of it. So you can look at things. Right now, the same thing as I talk about. The answer is double in this case. And then you have one more double variable here. And then integer variable. So in this case, they treat this integer variable as a double. So there's a conversion doing by the system. So you can see this is the number of birds, of course, but it will give you as a float number here. It's not, it's taken care of by the system. So this is an implicit conversion, right? So, but there are things that not always implicit conversions. In that case, you have to convert something by yourself. So this is another one like that. So in that case, we call it typecasting, right? Usually the static typecasting operator is a static underscore casting and then the type. So we usually use this as a template. You will learn template at the end of the semester. So this is the type is what kind of a conversion you need. That's what they're asking. So the variable can convert to anything else. Usually in C, we used to do is something like this, which is if I have a float or a double as my answer, and if I have two integers, int a and int b as my values, right? And so if I want the floating point answer for this, what I do is I convert this one to float. Usually I can say float a, that is a conversion, and this one can be float, I'm sorry, float b, right? Float a and float b, and this will give you answer in the float format. This is a conversion of integer to the float, conversion integer to the float. So this is what actually they're talking about here. Okay, so this is mostly in C, we write it like this. I think C++ also take this format as well. But here it is more meaningful if you write typecast and then the type here, okay? The example of this is right here. So this is calculating average something, but these values are integers. You can see it is an integer and integer, right? And this is also integer value, but your answer is double value, right? So in that case, if I want to convert anything, you can actually convert things. Even you have 3 variables here, but I'm worried about only the concern about the final add. After addition, I can convert that to a double and divide that by another double. So this is a typecasting, which means I want to get the double answer, not the integer value. So in that case, you can always use that. So this is a good practical one. Kids in a family is never going to be a float number. It's not going to be a 2.5. Kids, the people, right? Then always it's an integer value. And then, but if you calculate the average, obviously you have to have a floating point number. So in this case, this operation, whatever you're processing here, have to have a conversion, right? There's no other way of handling this. There's no reason that you put float here because of this reason, right? Because float takes more resources than integers. So if you want to fill up integer register with integer values, it's better that you keep it simple and the appropriate type instead of typing everything in float. So the only good way of handling this is you need the floating point numbers of this only if you're calculating average. Otherwise, you don't want to worry about it. So in this case, typecasting is important and useful in order to do this, right? So only if I have a floating point number, and if I want to calculate things and return as a floating point number, you can use this, okay? Right, so I think everybody understand that. If it is not, please raise questions or however the way you want to communicate. So let me know. Right. Okay, so the common errors here, accidentally perform integer division when the floating point division was intended. So this is kind of thing. You always get these kind of errors. For example, if I have very important these things, like for example, if I have 5 and 4 as my two families, and if I divide this by 2, right? This is supposed to be you get average as 9 divided by 2 is 4.5, right? So this is the answer it should be. But if you're using integer division, you get the answer as 4 right here. So that's what the problem. Or if I have 20 families and then this is the only number of children, it's supposed to give something average point something, right? But instead of point something, you will get the answer 0 if you have only the integer without converting this. So this is the one common mistake that people do. Keep in mind, if you have these values, because these all are integers here, you will get the integer output, right? Even even the integer output will be look like this, obviously. But the thing is, in this case, it will give you this. Okay, so if I do the only integer division, this is the answer it's going to give me, right? Because it's an implicit conversion, but it is do that conversion to the answer, not for these values here. So what I'm saying is implicit conversion means the system will convert the last answer and return it to this. So this will be 0.0 if I use this kind of problem. So it is not good. Okay, so make sure you do the typecasting if you're having a division like this. Right, so that's the second thing that you have to keep in mind when you're doing this. Those are very logical errors that most people made, and it's very hard to find. There's no way that I can detect this unless I spot this, right? Imagine that you have a big program with 100 lines, right? That means it's not going to fit in your, let's say, for example, this is your IDE or the developer tool, and you have like 500 lines of code. And you define this in the top of your program, which is somewhere here now, right? So you don't see that part. But I see A divided by B here as the answer, right? So when you go through this program, if you're not aware of this part, right, this program is perfectly fine. And whenever you execute this, it never gives you the right answer. So it's always giving a wrong answer, right? But you don't know. When you go through this program, you can spend hours, months trying to debug this part right here. But you never notice this because it's not showing here. It is on the top of it. So when you scroll down to your equation, and if you try to find the answer there, it's never going to come because you define these in somewhere else, right? So those are the common mistakes people do. Did you get what I'm saying? What I'm saying is if you have long lines of code or separate files on your code, in that case, when you're having encountered this kind of a situation, unless you are aware these are integers, you're never going to get the answer. So this is a good example, one good example for having a meaningful variables, and at least you can guess, oh, this might be integers because it has a number of people, and then you can go and check. If you don't have meaningful variables either, names either, and if this happens, usually it's very rarely you go and check the type. And then you do all kind of a debugging techniques that you know in your whole world to figure out what's going on in your program. So, okay, so it is simply the type, right? So this is never going to give you an error in a compiler or anything. So you may have spent a lot of time on it, okay? So keep in mind, those are very, very crucial things when you're writing code, okay? So that's what they're pointing out here as well. Okay, so that is that. The binary part, we talk about this. So let me skim through this very fast. This is the conversion of numbers to binary and then back. So I think you have heard this before. If it is not, if I have number 10, the binary form of this is you divide by 2, you get 5 and remainder 0. You divide it by 2, you get 2 and the remainder 1. You divide by 2, you get 1, remainder 0. So the 5 you can represent when you're writing this order of the numbers, 1, 0, 1, 0. So this is the representation of 10 in your register. right? Because you have switches, this is how it's represented. If you want to make sure it is 10, I can do is I give values for this. The first bit is 2 to the power 0. Second bit is 2 to the power 1. Third bit is 2 to the power 2. Fourth is 2 to the power 3, right? And then you multiply these values with this, right? So 2 to the power 0 into 0 is always 0. And 2 to the power 1 is 2. Multiplied by 1 is 2. And 2 to the power 2 is 4. Multiplied by 0 is always 0. And 2 to the power 3 is 8. Multiplied by 1 is 8. So this will give you 10 back. So that is a conversion. And all this one and then this one is talking about that, right? So any number, you convert it to that and put it up there. That's how we store numbers. So that's what they're talking about here. And then also, what does this mean? So it's showing it right here. Okay, all right. So yeah, go through that. If you want to get the answers of this, convert the binary number to a decimal. So I have what? 1, 2, 3, 4. So 2 to the power 0, 2 to the power 1, 2, and 3. So this is 15, right? So you want to check it's 15. So if you really want to check it, this is 2 to the power 0 plus 2 to the power 1 plus 2 to the power 2 plus 2 to the power 3. This is 8 plus 4 plus 2 plus 1. Right, 7 plus 8 is 15. Right, so that's what it is. Right, so those are the practice things that you can do. Okay, so I went a little fast on this because I talked about that earlier as well. So you might have a clear idea. If it is not, please ask. And these are important things when it comes to registers, okay? Right. So then the characters and the strings. So how do I show the characters in your screen? So this is one of the important ones in your floating point types. Okay, I mean the variable types. So this one is one character. If you have only one character, I can say this is a variable or one, right? So this is a name for that, right? And then you can say my var one is equal to character, which is a. You may use this to quotes in order to define or assign a value. You can notice it here, or it's here and then here. So always you have to have this is a single quotes, okay? In order to define, assign a variable with the character. Right, this is handling only one character. Okay, so keep that in mind as well. So if I want to put any symbol, like for example, I want to show this symbol, or I want to show this symbol, right? Or anything else, like for example, plus symbol or minus. Usually when you're writing a code, if I say var one is equal plus, this will consider as a mathematical equation, and then it will throw an error for you, okay? If I really want to store the plus sign in a variable, what you have to do is define the variable as a character and then put this little two quotes in there. Then it will be working fine, right? So that is what characters use for. So especially if you want to show something like that, you will use characters. Okay, that's a good example here. But make sure that you understand it is representing only one character. It is not a set of characters. If I want to represent a set of characters, either you have to use arrays, you will learn it later, or a dynamic space of memory of set of series of characters. What I mean is, if you know about arrays, arrays means, so this is one character is just a one square, right? A. Uh, if I want to make a word out of it, I have to have many of these. So in that case, usually I use a of 5. This is something I did not teach you yet. That's called array data structures. If you have array, of course, this will have 5 characters you can put A, B, C, D, E. You can have that many, right? So that is what this means, okay? Each one has one cell of representation of character, right? This is how you used to define the words and things like that in the C, especially. The C++ introduced something called string later on. So we're going to look at string next, okay? But early days, we had only characters, which is a CHAR, right? That is the definition. So in that case, if you're using a CHAR, it is representing always one character. Remember that, okay? Right. What else you should know about this? Oh, this is a good one. This is the character I'm inputting. So you can see it's already have a little box here to input things. So if I run this program, it will show you this. Why is it showing me this? Well, I'm using something called character as my variable and asking user to send insert an input, right, for this. So it's a cin. That means the user entered this one, right? And then I just printing it. So I'm printing it, and I'm printing it everywhere. And it will be look like this. So if I want to change this to plus sign or something, right? Then run this. Usually you get plus signs everywhere. So any symbol that you want to put it in there, you can, right? So what happens if I put something like this? Then what happens? Right, it's pick only one character, right? And then it's just showing it. The rest, whatever you entered here, is won't count because it's only one character. Usually this throw error, but in this case, it's handling it well. That's pretty good. So which character is this? Is it the last one or the first one? So let's check that. So if I have this at the last, so it's always pick the first one and then drop the rest. Okay, so that is what the cin, the good part in cin to take care of it. Right. How the character stored in the system? Well, if I have A here, usually it has the value stored as a number, right? So that's how the registers, because you know the registers are nothing but integers. I mean switches, right? Each one has 0 and 1, 0 and representation. So in that case, these symbols like A, B, C, D, right? You should have a way to store these values, right? So in this case, you have some sort of order mechanism in the system to store these as numbers, okay? So this is what they're using in order to store. So, okay, this is a decimal number, then I will convert it to a binary. Right? So then I can store it in these registers. So this is what basically it does. When you see a number, this is a program. When you run it, they'll come here and let the user let a number, right? The user let is the variable. And then I say user let A, so that is nothing but user let space is filled by 97, right? Actually, the 97, this is just an overview of the memory. This will store as a variable of binary numbers, okay? And this is what we call ASCII. So when you see the name an ASCII number, that means you store a character with a number here. Okay, so that is what we call ASCII number, right? Why is it ASCII? Well, it's called American Stand of Characters something. I cannot recall the whole name of it, right? Right. So so this is what ASCII means. You can Google it and see what is the statement of that, or what is the meaning of this. Standard characters, something. I can't remember. So anyway, okay, and so these are the ASCII conversions. So if it is a space, you have 32 for that, and if you have any other symbols like this, each one has the value. So this is called character encoding as a number in ASCII standards, right? And the binary representation of it. So actually, your switch store it like this. This is how the switch is storing those things, okay? And this is the actual number of it, okay? And this is the value that you see, right? So those are things I want to point out here. There are special characters like days. For example, try it out, it's pretty interesting. If you're using a cout, and I say something like this. And then if I want to jump to the next line, I use enter. So this is too long character sets right here. Instead of writing like this, I can write the same thing. Hello world. And I can write like this, right? This part right here will take care all this. You can try it out if you want. That's what it does. So what is this one do is you return your character pointer to this one. So is this. When you're having a slash n, it will be returned to this. Okay. So that's the new line. Usage of this is this. The tabs, of course, you will move. So if I have hello world just like that, cout hello world like this, you will keep some spaces here, and then you say hello world, and then quotes, and then end. To do this, instead of you typing your white space, you can do cout and slash tab T, and then write hello. Right, so this is the second one, this is the first one. Okay, so these both works in this case. So these symbols are very short way of writing things instead of writing like this or the keeping white space. So keep those in mind, it's pretty interesting and useful. One question I'd like to ask you is, right, so when you're having a program written like this, I want to print out, my output should be, should be like this. Let's say my output I want to show is apple as a word like this. Right? So this has double quotes. Does this program, what is the output of this? If I do this, what is the output look like?
It'll just say Apple.
It will say apple. But what I want to do is this with the double quotes. So how can I do this instead of this? So this is what they are talking about right here. So if I want to do that, you may have to use cout, right? Double quotes, and then put a slash and double quote, apple. And then again a slash and double quotes, and then the double quotes, right? If you're using this, if you're using this kind of things, then it will show you actually apple with the double quotes at the answer. Okay, so if this is the output, this is how you do it. So yeah, the slash with this. If you don't have the slash, obviously this is an error. This won't work. Okay. Right. So those are very tricky ones, but keep a strict on this one and make sure you understand all 5 of them. Okay. Especially for the exam. Right. Okay. So that is that. And play around with this. As I said, love yourself and learn by yourself a little. Okay, so this is 14. In 14, they're talking about the series of characters, and we just give a name called string for that. So I said, as before, if I have a string of characters, we call this var 1, and if I have 20 characters, I can put it like this. Instead of writing like this, in C++, they introduced something called string var1. So this can handle any number of variables. For example, but the structure of this actually is doing 20 cells. This is actually what it does. So that means this one and this one doing the same format of the structure if you go to the memory. So here you can see I define the string as a Julia, and each cell, each switch, each cell in the memory. So that means a set of switches here, right? There are a set of switches to convert this to an integer and then put it as a binary number. This is also a set of switches, right? To install U in there. This is set of switches to install L and I, and then so on. And each of these switches have address, which is a 501 set of switches, 502 set of switches, 503 set of switches. This is how the memory architecture is, okay? So what they're not showing is the switch set, right? Okay, but this is actually the structure. So in this case, yeah, if you have a J, that is only one character. So in this space, like one character, in the string as well, even you don't see the structure here, it's doing the same thing. So it doesn't show the structure, of course, but I can simply say string var. It will do this, but these two are different variable types, right? One from the other is distinguished, different, right? So, but the structure of the floating, on the memory map, it will be the same. Okay, so understand that. That is one thing I want to point out in strings. There are a lot of things that you can do with the strings, substrings, and there are so many libraries that you can use with the string.h. We will encounter those later on. I just want to introduce simply the variable type string here. So that's what I just pointed out, okay? String can have multiple characters, but you have to have double quotes. So in this case, is this the valid one? Yes, it is. And is this a valid one? Yes, it is. It has a double quotes. This one is not, because you don't have double quotes, and this is the integer value, so it's not, right? And this one is yes, because you have double quotes and a number, right? So this is treated as a string, not a number. And this one, well, you have single quotes. In that case, it's not, right? And this, yes, this is a character. Even if it's a one single character, it is considered as a string. You can like that. So that is how you. So play around with these things. I would ask you and test you on those. Okay. Right, string assignments, usually any string, you can use just the equal sign. Just like this, you can do it. There's no worries, okay? So just the equal sign will work, but you have to have double quotes for sure. Right? If you don't have double quotes, it's throw an error, okay? So make sure you have that as the string. And variable name. So just go through these things. I don't want to spend time on it. I have only 5 minutes. So, go over these. It's just playing around with it. And And one thing I want to point out here is the get line. Yeah, so the get line right here. There are two ways that you can insert variables for strings. So which one? What is the first one is if I have a string, right? Oops, I'm sorry. String A as the variable name, and I can say cin. The user can enter A, right? To work. And also, if I want to have a space in the front of this, cin, if the user come and do, if I say cin A, and if the user come and type something like this, so this is your terminal, and let's say I'll say enter a word. I see out something like this. Okay. Yeah. See out. Well, I'm sorry. This has to be this way. This has to be this way. This has to be this way, right? See out. I say enter word. So it's enter word. That's what you see here. Okay. Enter a word. Right. This is what you see, and you entering a word. So the user comes. Let's say he put some spaces in the front, and then he put A. Right? So he put some spaces in the front. But when you store this in the value A or the string A, it will ignore this space and it will take only the value. Okay, so if this is the word you put is apple, let's say for example, with the spaces, but here you won't see the spaces, it will take apple like this. So it's always ignoring the white space in the front. So that is one thing in the cin does. So check it out if you want. But if you really want to get these things, usually using a get line command. So the get line can take care of this white space in the front and have the apple as well, right? So that is a get line. You will learn about get line a lot when you're reading a files, reading a file IOs. So that means if you have a text file like a Word document or something, or the TXT or any other extension, if you want to read this file into your system, in that case, getLine will be very useful. So we'll talk about that later. Okay, right.